I'm going to explain you what we are going to do in this second part of the session, and then we will go into it. So this is the workflow for Eman. It's going to be shorter compared to Dynamo, and we have an optional part that if I don't think we're going to have time to do it. So again, it's explained in the tutorial, so you can follow it in the future. And if we have time after Dynamo and everything, we will have a look at it. So again, we will start doing some imports of our tomograms using the other import tomograms available in Scipion, which is the one, I guess someone was asking at the very beginning how to import tomograms without a catalog. This is going to be the one that is allowing us to do this kind of importing. Then we will be in our tomograms. In this case, we can use, again, I don't know, here we can use, for example, iMod, just to change and use some different protocol. And here we have one box we are not going to use, but I think it's nice to comment it. Eman Tomo plugin can install different versions of Eman. By default, it will install the very, very last version, which is the one that is working better. But in any case, this is not the very stable version of Eman. It is kind of the continuous build version they have, and it may have some bugs. We are trying to always test it before releasing a Scipion, just to be sure everything is working. But if there is a bug from Eman, there's nothing we can do. And we also offer the stable versions. Problem is that the stable versions usually don't like rectangular tomograms. They like that the tomograms have both the same dimension in X and Y. And this is the case for the picking we are going to use. So for today, it's not going to be needed because we are working with the very, very last version of Eman. But if you see any error there and you decide to install the stable version, just remind that probably you need to make your tomograms square before picking them. Then we have ways to go back to rectangular tomograms with the coordinates and so on in a Scipion, so it's not a problem. But well, this is just like a small clarification. And then we will use this ConvNet picking. Eman has 3 different pickings available. We have the manual picking, which is very similar to the one of Dynamo in general model mode. We have the template matching picking, which given a model, either initial model or any other volume we may have, we can kind of pick automatically all the particles that look similar to that model. And also we have this ConvNet, which is based on a neural network. This is the most accurate picking, most versatile picking. So in general, here you will choose, it's semi-automatic. You need to choose around 5 to 10 or even more particles. And you can train a network and afterwards use that network to pick all the different molecules in your tomogram. So for this session, we're going to be using this one, which is the most interesting one. And then we will learn how to do an extraction with Eman. And as I have said, it's the same as Dynamo. So if we don't have time, protocols form is exactly the same one in Dynamo and Eman. Both will do exactly the same thing. And the only difference is execution time. Eman Tomo is usually much faster than Dynamo, and that's why I would recommend to use Eman unless you have a preference for Dynamo for some reason. And then we have this other branch, which is in principle, we are not going to do it. I will just comment all this other possibility of picking. So other thing you can do instead of picking this with this network is to do a manual picking first with around 60 or even more particles. And the idea is to get those particles, extract them to get the subtomos, and you can run an initial model with Eman. This initial model, in general, default parameters in the protocol work fine. In Eman also, they don't recommend changing the parameters in their program. It's just creating a very, very initial model with low resolution. And then we can use that to run a template matching. Both of these pickings, the ConvNet and the template matching, will lead to very, very, very similar results. And the ConvNet will have, in general, better results compared to template matching. That's why we are not going to focus on this today. And then if we have time, I will also try to comment on the picking consensus that we have in Scipion, just for you to know how to use this tool. So I will do that at the end. So let's move to our other project in Scipion. So what we have done, Eman. One nice way, if you want to hide all these boxes, just in case you don't want to see all this while we are doing the other part of the branch, you can click on any protocol or any box, right-click, and you can click on collapse. And in that way, you can see that all the boxes below have disappeared. And here it says, hey, you have some box here and other 4 boxes that depend on it. And well, this way we can have everything more clean. It's not, if in case you want to do it, I like having things clean. So, well, it's another option Scipion has. So let's start by importing our tomograms. Firstly, we need to go to the Import tab here in the left panel. And we are going to choose this time this Import tomograms, which is kind of the default import that we have in tomography. So we double click on it. And this is the form. As you can see, it's different to the one we had before in Dynamo. This allows for more options. So first, we need to provide our files. So to do that, we can, again, click on the folder icon. And we need to go to our data folder. So in your home, you should have, again, your data, Day2, Eman Dynamo. And we are going to import this Tomo IS002 with this very long name, .mrc file. Since we are going to import just one file, it is okay to click it once. If you double click it, Scipion will try to open, and since it is quite big, it will kind of make your interface laggy. So just click once on it and click on select. And that way we already have the path. This is useful when we want to import just one tomogram. Imagine if we had several MRC files in that folder. Instead of just choosing one item in the folder, we can remove the file name here, kind of removing this part, just leave the folder, and we can write a pattern. Like, for example, a star MRC. I don't know why the star is not working for me right now. And I don't know where this is here. Here? Okay, star.mrc, for example. And this is telling Scipion, I want to import all the files that end with MRC extension that are present in the Eman Dynamo folder. Of course, you need to remove this, as I have said before. You cannot have a path and then a pattern. You need to have only a folder. And also, we can use other extensions. We can use EM extension or other .bol, for example, and so on. So for now, since we only have one tomogram, we can just use the file name. And the sampling rate, again, doesn't matter. For today, we are going to use a sampling rate of 2, which is the one that Eman recommends for this dataset. Again, it's not going to be important for today, the sampling rate. In the future, you should put here the sampling rate of your data, the actual sampling rate. And as it happened with the Dynamo protocol, we again can provide some acquisition information, either manually or with a file, just like with the Dynamo import protocol. And we can change the origin information. We are not going to change it here. Again, we leave it as default, and the Scipion will automatically choose the center of mass of the tomogram to be the origin for the coordinates. So if we click here, you see this one is much faster. It's just taking the file, and you should see that we have the set of tomograms with one item and so on. So, okay, now we have our tomograms imported. If you import the tomogram, the CTF estimation can be made. I think CTF estimation is done at the level of till series only. We don't have anything at the level of tomogram. So you will need to import your till series with the import and then do the estimation there. So I guess it cannot be done unless you import the till series also. Okay, I see people writing in the chat. I'll answer. Okay, so I'm going to continue. Now we are going to be in the tomograms. We can use again Dynamo if you want, but just to change it, let's use the normalization protocol that we have in iMod, for example, just to change. So here you have one protocol. If you look for normalization, you can do Control F in the Scipion interface. And you will see this kind of search of a protocol window. You can write here any protocol name, plugin, or word that refers to that protocol. In this case, normalization will pop up these two protocols.
David.
Yeah.
Sorry, could you repeat which file have you selected?
Yeah, sorry. I will repeat it. So you need to go to in your home, you go to data, Day2, Eman Dynamo, and it is this one here that is kind of Tomo IS002 and so on, .mrc. Okay, just click it once to not opening and select it. Okay, you should have it there. Okay. So you look here for normalization. You will see the one you used yesterday, which is for tilt series, and also you have one for tomograms. This is the one we're going to use today. You can see it's very similar form to the form you saw yesterday. But instead here, we need to provide a set of tomograms. So we just click on the magnifier, and we need to select the ones we have imported right now, which are the first ones in general. So we select them. We apply some binning. In this case, a binning of 2 is going to be enough. And we don't need to change any of the other options here. We will just leave them as default. Okay, and just click on execute. And this should be in the tomograms. It might take some time, but you can again see in the output log how everything is going. Yeah.
David?
Yeah, I can hear you.
Yeah, please. Could you repeat this last step, please? A little slower?
Yeah, the one of the tomography.
Yes.
Yeah,
Thank you.
I have used Control F to search for it. It's the other way to look for protocols. And I have right here normalization. You can write also I mode and it will also appear. So once you write it, you click on the magnifier and you will have these two protocols. This is the one you used yesterday. And this Thermonormalization is the one we are going to use today. So you double click on it and you will be prompted with the form of the protocol. And the only thing we're going to change in the form is the input set of tomograms, which with the magnifier, we can see all the tomograms we have imported. Of course, we have the ones we imported before with Dynamo. We're going to forget about these ones. And we are going to choose this first one, which is the one we have just imported with the other Tomo import we have in the Scipion. And you select it. And then we are going to change the binning. And we are going to put it to 2. And as I explained in Dynamo, this binning of 2 means dividing a tomogram by 2. Remember that in Dynamo, the convention is different. A binning factor of 2 meant dividing a tomogram by 4. Here in IMO, the binning of 2 is really dividing by 2. Okay, so well, different programs have different conventions. And once you have this, just click on execute, and it should take some time. Okay, so let's wait until it finishes. And if you have any other question in the meantime, you can click on refresh to see if it had finished. Seems there were some problems, but Jorge's already trying to solve them.
It's not directly related to Scipion, but since you took over my machine, my window doesn't fit my screen anymore. Do you have an idea how to fix that?
I think, in fact, I had the same problem, and someone fixed for me. I don't know who did it, but if
okay,
that person can give you a hand.
Try to log out and log in again.
So just log out of VNC and
or close.
Re-enter again.
Close the tab and enter again. Yeah.
Thank you.
Okay. It's taking some time. I don't know if this is normal or not, but if it doesn't finish, we can use another binning protocol, no problem. Though it should finish.
And when I leave, while it's running, it doesn't create any problem?
No, I don't think so.
That's a remote machine working on its own. I mean, you just close the tab. Don't use the logout on the top right, because that's a Linux logout, and that will actually log you out of the account. But there's on the left, on the panel that slides on the left, there's a logout option there. I'm not sure if I'm explaining it.
It seems this protocol is taking some time, so probably if it's finished for you, fine. If it doesn't, I'm gonna write the one of Dynamo.
Yeah,
it seems
it's taking too much time to write the file. But if you go to the extra folder, you can check that the file is being already written, but it's taking too long to be generated, fully generated.
Okay, so probably either, I don't know how much space it will, I guess around 1 giga. So we can wait a little bit. In the meantime, I can explain you the parameters for the picking protocol. Okay. So if you go again to the left panel in the Scipion particles tab, and you go to picking, here you have all the Eman programs I explained before that will allow you to identify particles into the tomogram. The Tomoboxer is the manual picking. Template matching is the one based on a model, an initial model or any other volume. And we're going to work with the third one, which is the Tomoboxer CompNet. Okay, so we can double click on it. And this is the form of the protocol. As you can see, it's relatively simple. So you just need to provide the tomograms. We don't have them yet, so let's wait until the file is written, and we will be able to give them. Then we have the box size, which is the box size of your particles. By default, is 296. It has a reason for it to be 96. And I will explain it later, but it has to do with the network that Eman trains. So you can change it to any value you want. So in fact, for this tomogram, 96 is fine. Also 64 is fine. I'm going to choose 64, but any relatively big value is relatively fine. So 64 should work. And then we have a new parameter, which is the group ID. And this was not present in Dynamo because it wasn't needed, but it's needed for Eman. So the idea of the group ID is to tell a Scipion that the coordinates we are currently picking should be considered to be always together. So imagine, for example, in the case of the tomogram with two vesicles. So we don't want the particles in one vesicle to be mixed with the particles in another vesicle. We would like them to be separated. For example, even to define directions. It doesn't make sense to define a geometry that depends on both vesicles. Just we need one geometry for one vesicle, another geometry for the other vesicle, for example. So that it is done with a group ID. So what the Scipion is doing is telling, okay, so all these coordinates in one vesicle, let's give them group ID 1. So they are one group. And the coordinates in the other vesicle, they are group 2. So now a Scipion knows that even if the coordinates are in the same set, those two must be treated separately. This also can be useful if you want to identify different types of particles in your tomogram. So if you have ribosomes, another protein, you can also play with the group IDs to identify in the same set of coordinates these different particles. That's why it is here. By default, a Scipion will give a 1. But if, for example, you want to pick again this tomogram because you find other things that are interesting and you want to keep track of them, you can change the ID to 2, 3, 4, and so on. ID is always a number between 0 and infinite. Okay. Yeah, it's not. In the future, we would like to give them names like ribosomes or vesicle, but right now it is an integer. It's a number between 0 and infinite. Okay, let's see if this finish is taking more time than expected. Sorry for that. Let's see. Yeah, it should be around 1 giga. So let's wait a couple more minutes. And in the meantime, I can explain you, for example, the forms for the other picking protocols in case you want to use them at some point. So I'm going to explain the Tomoboxer. Again, we are not going to use it, but since we are waiting for the protocol, we can have a look at it. So as you can see, Tomoboxer is also similar to the other form. Just needs input tomograms. And also you can modify a set of coordinates that you have done previously, even with Dynamo. So for example, you have picked some coordinates with Dynamo, but you like a lot how Eman shows the preview of the tomograms and the boxes and so on, and you decide to refine your picking with Eman. So here you can provide a set of coordinates to be used in the picking instead of creating a new one. And here you don't see group IDs, and this is because the manual interface of Eman has its own window to create labels. So we don't need to, in this picking, we don't need to give just one label. We can create all of them directly with the manual picking of Eman. So this is the second option we have. And the last one is the template matching, which is this one below. This one has a little bit bigger. Seems to be done for Dimitri. It's also done for me. Is everyone done with it? Can you input coordinates? Yes, you can. You can input coordinates created by Eman into Dynamo. Problem is that if you remember, coordinates in Dynamo were not a set of coordinates. They were a set of meshes because Dynamo considers them, or we are making the distinction between coordinates to be extracted and coordinates to define a geometry. So there's a specific protocol, which is in Dynamo Chords to Model, I think it's called, which takes a set of coordinates and converts them to a general model in Dynamo. So you can afterwards give them orientation with a membrane in Dynamo and so on. But yes, you can do it. Okay, some people are still running. We have some people already done. It's done. Okay, I will explain later the input for the template matching. Okay, let's move to the ConvNet.
Sorry, my protocol of Thermonormalization says it's finished and something popped up. So a slice showing window, but in the field it still says it's running.
Yeah, okay, that's weird. Probably there was a problem with the analyze result. Can anyone check?
I got to your machine.
Okay, thank you. Yeah, refresh may solve it, and probably the issue with the kind of slice view is because by some reason the analyze result just security itself or something like that. But if Pablo can check. Okay, so let's go. So let's choose this Eman Tomo boxer as we did before. Double click on it. We can choose our input tomograms. In this case, are going to be these ones coming from IMOF Thermonormalization using the magnifier. We just select them. Box size, if you want to leave it as 96, is fine for this practice. I'm going to use 64 just to make it a little bit smaller so we don't have like a very big tomogram at the end, but it's fine. It's not going to be so important. Also, as I explained before, this box size is not forever. You can change it afterwards if you don't like it. Okay, and we click on execute. And this program won't pop up the tomogram dialog that appear in Dynamo. It will directly open the interface of Eman because Eman already provides a window to select tomograms in the set. So that way the protocol is simplified. Okay, I'm going to close this window. Okay, I'm not sure if it already appeared. It doesn't seem like it. So let's wait a little bit. Okay, so yeah, you should see a lot of windows. I'm going to explain all of them. Is there any question? I think. No? Okay. I'm going to explain all of the meaning of all these windows. Okay. So no worries, Imbar, no problem. So okay, so we have the main window is this one, the one that is called E2SPT Boxer ConvNet. This is where you will be able to change all the parameters related to the convolutional network, opening your tomograms using this part here to the right that has the name of the tomograms, see the number of particles you pick, the number of particles that the network picked, and so on. Also, you can change the parameters of the network. I'm going to explain more or less what these parameters means, although in most of the time there is no need to change them, okay? So there are two different ways to train the network. I'm going to start from the bottom first, which is the sum and the max. This will change the way the network identifies the particle in the box. In general, sum is working for most of the particles. If the documentation in a Scipion has some link to the page of Eman where they explain this. Max is only used for very, very, very specific cases. It will train slower, and it might not work as well as sum. So in general, this parameter here is better not to touch it. Then we have, well, the references of particles. This depends on what we want to train. So by default, we are going to train on the reference dataset. I'm going to explain what the reference dataset means. But also we can train with the particles that the network has found. So this is what this is doing. Then you have the target size. Target size is determining what is the size of the particle in the box of the image that is going to be used in the network. So depending if your particle is bigger or smaller, you can play with the value here. In general, there is no need to change it. Leave it as 1 and it's fine. Learning rate, again, determines how fast the network is going to be trained. There is no need to change this. Most of the time, just leave it like this and it's fine. Particle threshold determines, it's kind of giving a threshold to avoid getting particles with a high contrast. So to avoid gold bits and all these things. You can also train the network to avoid this. In general, I haven't touched it to pick, but well, it's there, available. Target size 1 angstrom, 1 pixel. I don't really know. Eman doesn't explain the units of this parameter. It has to do with the size of a blob. Okay, it's kind of Eman is going to convolve this image with a Gaussian and make the particle a blob. So it's the size of the blob, but they don't explain if that size is in pixels or in angstroms. I don't know. Sorry. Then you have the circle size, which is kind of a distance threshold. So it's going to determine if particles that are within this distance. So let's suppose that we have two ribosomes very close together and the distance between them is 24 pixels. I think this one is in pixels. So if the distance between them is smaller than 24, Eman won't consider them as a particle because it's impossible to pick them separately. So you can play with that parameter. Number of iterations to train the network. This will depend on how the network is training. I will show you later how to check the training. And you can set here a larger number of steps, which is going to take longer time, but in principle is going to train better, or a shorter number, a fewer number of steps. And then this post-mult has to do with, again, with the pixel values. It's not so well explained, and Eman doesn't recommend to touch it, so it's better to leave it as default. For now, all these parameters, we won't touch them. It's fine with the ones we have here. Then here we have the buttons to work also with the network. We can create a new network. In fact, if you want, you can do it. But if you don't create it right now, when we click on train the network, Eman will automatically create one. So if you forget to click here, there's no worries. Then you have the load button. This protocol is also interactive, and if you save the network with this button, you can afterwards open it and load it again to retrain it or to create a new one or whatever. And then we have the train button to train the network based on these parameters. The change box, this is not the box of the particle. This is kind of confusing. This box is a number between 96 and infinite. It cannot be smaller than 96. It's measured in pixels. I cannot see the share screen. Is everyone having the same problem? Can you see my screen?
Yeah.
Yes, I can.
Okay, so probably, I don't know, probably if you restart the connector, it will appear again. Yeah, how I open this screen? You need to create a new TomoBoxer ConvNet protocol. And then you provided the tomograms there. In the first tab, you will see the input tomograms, the magnifier, and you can choose the tomograms coming from the IMOD Thermonormalization. And then you just click on execute. And this window should appear after some time. Sum and max. Yeah, sum and max has to do, let me open, with the way the network is trained. It has to do if it's going to use like the sum of the voxels and kind of an average to train the network in the image, or it's going to use the maximum voxels there. In general, you don't have to touch it. Max is going to train slower and is going to be much not so accurate. It's only for very specific cases. So sum is the preferred option. So as I was explaining, this box size is between 96 and infinite. And it is the size of the image that goes into the network. Doesn't have to be the same as the box size of the final subtomograms. That's why it doesn't matter if you have a very box size in a low binning, because Eman is going to be intelligent and that extra information is going to be taken into account. So in general, it's set by default to 96 and there's no need to change it unless your particle doesn't fit in the box of 96. And the apply all is to apply to all the tomograms. We will see how to apply to tomograms. Then we have two other windows that I will be explaining while we are picking. So let's open our tomogram. You can just go to this window here and click on it. And after clicking, it will open after some time, okay? The normalization, yeah, the Thermonormalization protocol, which is the binning protocol from IMOD. If you have used a different one, if you have used a one from Dynamo, you need to pick the tomograms being with that protocol. Okay, so I think it opened the tomograms. So we should have here the window with our tomogram. And I'm going to open also these other two windows. Sorry, particles. Now, particles is not going to be needed for now. I'm going to open the windows of positive and negative. These ones are important, okay? I missed what you did, that the interface was yeah, I click on the, to open the tomogram, I click on this E2 SPT window, and I click on the name that appears on kind of this table. And after clicking it, the tomogram will open after a small period of time. So basic controls in the Eman viewer. So I'm gonna wait a little just to see if Bram can open it. Great. So basic controls. To zoom in or zoom out, you can use the scroll in the mouse, the wheel, okay? You can zoom in or zoom out. Then if you right click, just right click with the mouse, you can drag the view. Then we have two different ways of, well, if you click on the middle button of the mouse, you will open this window that will allow you to change the contrast in the tomogram and so on. Here we don't really need it. We can see the particles, but you can play with that if you like. Also, we have this N here, this bottom line, which is useful to use to change the slice in a fast way. Okay, just by dragging it. Other way of changing the slice is to use the up arrow and down arrow keys in your keyboard, and you will be able to change just by one slice. And then we need to learn how to pick. Here we can pick two different types of particles, which are these blue circles, which are called positive particles. And you can see that when I pick up positive particles, the positive particle window updates with that particle. And if instead of just left clicking, you do control click, a control keyboard click, you will see this red circle. And this is a negative particle. So in the Eman network, we can train the network to find with those positive particles, which are the things that we want the network to find, and with negative particles, which are those things that we want the network to avoid. So for example, Golby, it's these membranes here, even regions with no particles, and so on. To delete the peak, you can do it in several ways. You can go to the particle in the tomogram, in the circle, click Shift and left click, and you will delete it. Other way of doing it is to go to the window of the negative, positive, and so on, which is showing you the preview. And again, you can Shift click and click on one image, and it will also delete it. Okay, so you can use both ways. Yeah, to see positives, you need to left click, and you will see on any region on the tomogram, and you will see this blue circle. And if you control click instead, left click, you will see the red circle. Is fine?
David?
Yeah.
And to delete one of the circles?
You can either click on the cycle with Shift and click, Shift in the keyboard and left click, and you will delete it. Or you can go to this view where you have the positive and negative images, and you can Shift click on an image, and it will also delete that. Yeah, blue circles, you can click the left click of the mouse will place the blue circles, which are the positive. And the control plus left click will show the red circles, which are the negatives. Okay, great. So the idea is to pick some positives around, Eman recommends at least 5, but you can pick more. I'm gonna pick, I don't know, around 10, 20, doesn't matter. As long as it is more than 5, it's gonna be fine. And then we are going to pick also some negatives, which are those regions that we don't care. So I'm gonna go to open this window again. And I usually, if you move the slide a bit up, you end up in kind of this slice where you can see many ribosomes kind of alone. So it's very easy to pick those as positives to train the network. Because in the other slices, you see that it's kind of crowded. So although it doesn't matter in principle, but well, I like picking this area more. So I'm going to start picking some of them, okay? The info box, you can click on the central button of your mouse, click on it, and you will open this box here. How did you open the window of the peak? The peaking is the peaking, this window here, the one of the tomogram? On Mac, control left click is not working for the negatives. I don't know if in Mac changes the key. I don't know if probably with this option key might work. I don't know how it works in Mac. I don't know if someone has a Mac and can help. The brightness window. Yeah, just go to the window of the tomogram, and in any place, click on the central button of the mouse, on the wheel, and you will open this window here. Yeah, on Mac doesn't work. Yeah, I don't know how to pick in Mac.
If you're using no VNC, you can simulate the control. There's a slider on the left, but this is not very user friendly.
Yeah.
Maybe you can show them. I don't know if you have no VNC access.
I can try. Yeah, I'm gonna just answer this question. How to direct peak particles? You go to either the tomogram view and you put the mouse on top of the circle and do a shift click, and you will delete the particle. Other option is to go to the particle list, to this list, and shift click on the image. Okay. And the one of no VNC, I can try to connect. Just 1 second. Let me. Okay, I don't know why this window minimized. Okay. Can you see the no VNC window now? It's kind of big for me, but I guess Pablo refers in this place, right, Pablo? Because I have not used no VNC, but I guess it should be here, right? In the show extra keys, probably. Or...
Sorry, I was muted. Yeah, click on that icon.
Okay. Oh, yeah, here, right?
Yes, and then you click on control, and that is like pressing control. It's a bit annoying because from that point, your control key is pressed, right? So you just need to press the other key or do the mouse action, whatever. But then you need to click it to unpress the control. It's not very friendly, but it might help with Mac users.
Yeah, probably this will help. Thank you, Pablo. Okay, I'm going to close the Turbo VNC. So, okay. And I'm going to move the chat to the other window. 1 second, so I can read you at the same time. Yeah, Control plus left click on the mouse for negatives. Scale. Okay. Okay, so yeah, the negative is kind of something you want to avoid in your final set of coordinates. So for example, a gold bit, you don't want a gold bit to be picked as a ribosome. So that will be a negative particle. Okay, so I'm going to start picking some, just for those of you that are already here, you can pick some of them. At least 5, I usually like picking more, but yeah, probably you can follow what Pablo said. You can, if you are using no VNC, you can use the menu on the left, and there is when you open the menu, there is on top a show keys, show extra keys, and then you can simulate the control. Probably that will help. Okay, so I'm picking several. Again, number is orientative. I'm going to pick almost all of those that are fine here. So these are my positives. Again, not so many, but it should be fine. And as you can see, if I go to the positive, I have a list of all those particles that I pick. Okay, with for the ribosome. So these are the ones I have. So now I'm going to pick the negatives. For example, I'm going to pick gold beads. For example, like this one. I don't like these areas here. Yeah, in principle, it should be more or less centered in the box. It doesn't matter if they are not completely centered, but they should be more or less in the middle. In fact, I have particles that are not exactly on the middle. So it's, yeah. So this area here, I don't like it either. So I'm going to pick some particles here. And I'm going to change slice, and I'm going to search for other gold beads, for example. We have some here. Some here, seems fine. Also, I'm going to pick this membrane. I mean, this is just like very orientative, as long as you pick the ones that you like. Also, do not place particles too close. Try to leave some space in between the circles, because this circle size is kind of the distance threshold. So if you put particles on top of each other, probably the network won't train that well, okay? And I'm going to go to the first slice where we don't have particles, and I'm going to pick randomly some points here with no particles, just to pick some. Okay, so right now we have our negatives. We have picked more negatives than positives, it shouldn't be an issue. Then we have the positives, which I can see the window right now, but it should be somewhere. Let me open it again. It's here. I have also the positives. So now it's time to train the network. So if everyone is everyone more or less in this step to start training the network, it's going to take a little bit of time. Okay, so we need to open again this E2SPT window. Once we are here, we need to click on train. That's all. So we click it. Now the interface will freeze. If you try to click anywhere, it won't work. Although the click is registered. So once the training finishes, all those clicks will start appearing in the interface. So just don't click, just wait until it finishes. And we can check the status of the training going to a Scipion and going to this output log that you have in the bottom panel. And if you click here on refresh in the panel, you see, okay, we are training. And you should see that this cost should be decreasing. Sometimes it doesn't. Sometimes it does. Sometimes it's faster. Sometimes it goes to a lower number. It depends on how well we have trained the network, okay? And the particles we have chosen, if we need more particles, if we need less particles, and so on. Principally, it should go down. I hope today Eman is working, because this doesn't seem to go down. But hopefully it will. If the training doesn't work, don't worry, we can move to the sample project. Sometimes training the network is hard, and it needs more picking more particles or tuning some parameters. And since we don't have a lot of time, we can go to the sample project and just see how a picking looks, okay? But if this does not work, fine. It's a matter of picking more positives, probably picking a little bit less negatives, and refining a bit the training data set. In my case, it's not decreasing that fast. So probably I will need to pick more particles. Not even decreasing, in fact. So, well, seems Eman today, yeah, seems Eman today is not behaving properly. Don't know why. Probably we need more particles. That will be one of the reasons, okay? But yeah, today it doesn't seem like it. It's not a day. Sorry for this. It works most of the time. Probably we need to pick a little bit more. That's all. While this finishes, I will just explain. Once this finishes, after picking, you can click on train, and it will start training. And then in this window of Scipion, in the bottom panel, you can see the status of the training. In my case, I should pick more particles. It's not working fine with the ones I have picked. Yeah, 120 particles. Well, those are too much. I mean, those are many particles. It will take more time, but probably for you it will work better because it has more information to train. But the loss is decreasing, right? Because I have picked very few particles. I am just in the limit of what Eman says it's fine. So here is the 0.05. Your network is training fine. In my case, as you can see, it's not training well. So it will be a matter to go to the particles and pick some more. Okay. I would train in around, should decrease around 0.06, 0.07. If it hasn't decreased to that point, you can click train again, and it will retrain until the loss decreases. Kind of manual. You need to keep on looking at your loss and see if it is in a low value, but it should work.
David, I've pressed the train button, but it doesn't work. I think I choose quite a lot of particles, but it doesn't work.
In the output log, you can see the iterations and so on?
No, it says save particles to 0.
Just because it seems like you have clicked on apply or something like that. That's the message that appears when apply is clicked.
Okay.
So I'm not sure if probably there was something wrong there. Can you try to click again on train and see if it's
I'm doing it, but nothing's happened.
Okay, can someone move to a breakout room with Maria Jose and check why this is happening?
I can go, Maria Jose. I can go to.
Yeah, I mean, if you have many particles, train will be slower because the training dataset is much larger. But in principle, you should train the network better. In my case, I was too optimistic. I thought with those particles was fine, and it hasn't trained well. In fact, in my case, if I try to apply the network, I won't get a result because it's not really trained. If you want to apply your train network, you have two different ways, okay? I'm going to explain it. Yeah, also depends on the GPU. Also depends in if you have or not GPU. If you don't have GPU, the protocol will run on CPU and train will be much slower. Okay. So the way to apply it is to go to this E2 SPT Boxer ConvNet, and there are two different ways to apply the network. One is to click on apply. This will just apply the network to the tomogram that is currently opened. Okay. Since we have just one tomogram, it will do the work. And this is very useful to check if for the tomogram you have been picking good advanced references, it works. If you click on apply all, you will apply to both open and non-open tomograms. Okay. And yeah, you click on apply. When you are happy with the value, just click on apply to apply it to the current open tomogram, or apply all to apply to all the tomograms. And once you are happy with the result of the apply and it has finished, you can check if it has finished again in the console. I'm going to do it, although in my case it's not going to work. Okay, it's going to say no particles peak because my network was not well trained. But if I click on apply, you will see here saying preparing input, applying to tomogram, name something, and so on. And it will also report the number of particles you have picked. Okay, it takes a bit of time. Finding boxes here, save 0 particles. In my case, I need to train the network better. I need to pick more particles. It didn't train. In those cases where you have a loss decreasing, probably you will pick some particles. So that's also this is indicating if you need to train more the network or not. So it's also kind of nice that this is just to see that we need more particles. And then do not forget, if you are happy with your network, do not forget, before closing the protocol, click on save. So the network is safe in the folders of Eman, and you can reuse it afterwards with the load. Otherwise, you won't be able to reuse it, okay?
Hello, sorry to disturb.
Yeah.
When I
pick
the particle, when I do the control plus left, I cannot see the blue circle.
You cannot see the blue circle in this window. So So when you left click, just to see if you don't see this, right? Or
No,
oh, after applying to a tomogram, you mean?
no, I don't think I cannot see it.
Yeah, they don't understand the question. Sorry, can you repeat it?
Because when I want pick a particle and I do the control plus left, I cannot see the blue circle. I don't know why.
Yeah, the blue circle is not with control. It's just with left click
Just the left
of the
click.
mouse. Yeah, just the left click of the mouse. And the control left click is for the negatives, for the red circle.
Oh, but when I do a left click, I also cannot see anything.
You don't see it. Can anyone go to a breakout room with by who? I hope I said the name right. To check why this is happening. Probably there's a problem with the visualization or something.
Okay, thank you.
Yeah, you're welcome. Okay, so for those that have trained the network and apply it, what you have to do is just to close the windows, okay? No, when you click on save, you save the network, only the network, okay? If you want to save the particles, just close all the windows in Eman, and automatically a Scipion will save the particles for you. In my case, it's going to be just a set of 0 items because I don't have anything picked, okay? For those of you that train well, you will see here your particles. Yeah, could be also the particle threshold. So it's just fine-tuning the network. So if you don't see it decreasing, it's an indicator that you need either to change some parameters, pick more, and so on, okay? It's not that it's not working. It's just you need to tune a little bit more the training. I'm going to move to the other project where we have everything run, just to show you how to run an extraction and how to open Tomo3D to see this picking, okay? And we will finish with that because we are running out of time and I don't want to take more time. So I will go a little bit fast on this. So probably it is better if you can just see my screen now and see all these protocols, how they work. And then if you want, you can repeat them before the other practice. Sorry, probably I was too optimistic with the time and I haven't taken into account the photo and also and all these things. Sorry for this, okay? I apologize. So I will move to the project where I have everything run. Yeah, if the window is saying busy, it means it hasn't finished either training or applying. So just don't close it. Just wait until it finishes, until it closes by itself. Okay. That's the other way to check if something is running. One is with the Scipion log, and the other one is to click anywhere in the window and see if it says the window is working. Do you want to stop it or wait? Just wait until it finishes. I don't know why Eman does not have a way to report this, but yeah, it is due to that. Okay, so in my case, if the ConvNet runs fine, you will get a different number of particles each time, depending on how you train. So in my case, I got 407. So it depends, you know, how well the network train on your parameters and so on. One way to check if your picking went well is to, again, right-click on the output. You will see all the different viewers. We can choose Eman or Dynamo, but since we have already seen the interfaces of these two softwares, let's work a little bit more with Tomo3D. If you click on Tomo3D, you will see this kind of tomogram dialog. You just double-click on any item of it, and the Tomo3D window will pop up. It might take some time. Let's see why it's not appearing. Yeah, I don't know why it shouldn't take that this long to appear. This is weird. Let me check. We don't have the console here to check, but probably there's a problem with this sample project and the paths. I don't know, but it should pop up a window. I don't know why it's not working for this project. Well, in your case, it should appear a window with the coordinates, and you should be able to see all the coordinates in purple. I'm going to open, just to show you how it works, the one we did with Dynamo, that seems to work. And you can just check with the one of Eman. This is just for do some checks. I don't know why it's not working in this project. It seems to be something weird there. So just I'm gonna check with the one of Dynamo. Okay, you can do it with the one of Eman. It should open. So I'm gonna do it with this one, for example. Yeah, this one's open. So there has to be a problem with the paths in the sample project. We will have a look at that. So you want to check the results there. You can see why this is happening. But you should see kind of your particles. In your case, you should see many particles because you're picking. Oh, it was taking a long time. That's all. Great. Okay, so I have opened in 3 times. So we can go with the one of Eman. Sorry for that. I didn't know it was taking that long. So this is my picking with Eman. It's, as you can see, many different things. Okay, and we have some boxes here. We can, for example, toggle directions. In this case, since we have a non-directional picking, all directions point upwards, meaning no directions, okay? Yeah, it depends. Probably you need, but if it is still on the first iteration, it's probably going to take some time, okay? And then also we can toggle here the tomogram in 3D. So when we do this, here you will see a window, which means Scipion is loading the tomogram and is doing some operations. So in the meantime, you can still play with the viewer, okay? And when you do this, it lags a lot, as you can see, and you cannot view very well the contrast. If you have a look at the screenshots in the tutorial, or if you open it in your local PC, you will see much better contrast. But just for now, trust me, that all these points that we are seeing here, you will be able to see very well that they are the ribosomes, and you will be able to check if the particles have been picked well or not. The output of the ConvNet picking. You just right-click on the output and choose Tomo3D Viewer. You can also open here a slice mode with the button. I'm not going to do it because due to connection issues, it's going to be like crazy. And also you can remove particles by clicking on point removal. I'm going to close the tomogram for now. So it's going much faster. If you click here on the menu point removal, now if you do nothing, you will be able to navigate. But if you press the R button, you will be able to draw this kind of rectangles, and all particles inside the rectangle will be deleted. Okay, so it's very useful to delete fast those particles, that a huge number of particles that is not that are not well picked. Okay, so this is one of the viewers. We also have the one of Eman and the one of Dynamo that are very similar, in fact, the same as the interfaces we have just seen, with the same controls, with the same way of modifying particles and so on. And just to finish, and then we can go to have lunch because we are a bit late already. I'm just going to show you how to run the extraction with Eman, and Dynamo form is going to Dynamo extraction form is the same one. So the extraction, you can find it here. If you go to the tomography tab, in the particles, the bottom menu is extract, and here you have all the different extractions available in a Scipion. We are going to use the one from Eman Tomo, extraction from tomogram. Okay. You also have an extraction from till series, and in principle, it's going to be used for per-particle per till workflows and so on in Eman. But for now, we only have tomograms, so extraction from tomogram. And if you click on it, this is the form. So basically, you need to provide your input set of coordinates. In this case, it will be the one you have just picked with the ConvNet picking. You should see here some, well, here we have a lot because it's the template, but here I have the TomoBoxer ConvNet output 3D coordinates. Okay, in your case, it will be the first input. Then you can decide if you want to extract in the phase tomogram that you pick, and this is the default option, or in other tomograms. For example, to extract at other binning. and you can, Scipion will take care of the change in the sampling rate and so on. So for now, you can just leave same as picking. You can also specify the box size, either with the wand, which will use the box size that we have used in the picking, or you can choose here any box size you want. From this point on, the box size is forever. We already have the tomograms. Of course, you can crop them, you can pad them, but you cannot if you want a different size at the level of extraction, you need to re-extract. You can also downsample. You can also downsample the tomograms by a given factor to make them small. And in the pre-process here, this was what Bram was asking in Dynamo about the contrast. You can invert here the contrast of your tomograms. So it's of the tomograms. Even if your tomogram has a different contrast compared to the one you want, you can just invert it here, and also you can normalize the tomograms. And once you can leave this also default, or if you want to invert to have a white particle because the tomogram in Eman was black, you can invert it. And once you have all that, it's just clicking on execute, and that's all. The extraction will run automatically, and you will get your particles. And this is everything for today's session. I just want to make a very brief comment. Just in case you use the extraction from Dynamo, Dynamo will remove automatically particles that are very close to the edges of the tomogram. So if you in Dynamo see that you get a set of tomograms with a fewer number than the coordinates you have initially, is normal. It's because some coordinates were in the borders. In the case of Eman, it will extract all the tomograms, and those that are in the border will have kind of a black line or strip on top or on the side. Okay. And here you can see it ran well. And if you click on the Analyze Results button or left click and on the viewer, you can see the tomograms. So you can see here we have the ribosomes, and in this case, the box was a bit large. But well, for the practice, it's fine. Also, some particles do not look well. Here we have the ribosome, but we have a goal where we can try to select here better particles. And that's all for today's session. Sorry for the time. We were 10 minutes. We finished 20 minutes later. Sorry for that. And well, if you have any other doubt or otherwise, we can go and have lunch. And then at 1:30, we will have the session of Jorge, and he will be talking about tomosegment TV, PySeg, and other software very interesting to pick from memories.